U is equal to fxy. This is the utility function of any consumer, and the budget constraint is given by x px plus y py equals to m. This is the budget constraint of the consumer. So what you have to do is that you have to maximize this utility subject to this constraint. So you'll form the Lagrangean function, which is f of xy plus lambda m minus pxx minus pyy. Okay, so what you will do is that you will find three partial derivatives, one with respect to each variable and one for the constraint. So del L by del x, which is say Lx, is fx minus lambda px equals to 0. Del L by del y, just say Ly is fy minus lambda py equals to 0, and del L by del lambda is m minus pxx minus pyy equals to 0. So this is equation 1, 2 and 3. So you can write equation 1 as fx equals to lambda px, and equation 2 as fy equals to lambda py. Dividing 1 by 2, what you'll get is fx by fy equals to px by py. This is what you'll be getting. And what is fx by fy? F of xy, they are the, x and y are the two arguments of the utility function. So fx is basically del f by del x, fy is basically del f by del y, which should be equal to px by py. But what is del f by del x? This is marginal utility of x upon marginal utility of y. And what is mux by muy? That is nothing but mrs. And what is px by py? This is the price ratio which you have. So at equilibrium, mrs should be equal to the price ratio. Okay, now what you will find is that how to calculate the second order conditions, how to find out whether second order conditions hold, and this indeed is the maximum point. So what you will do is that you'll form the bordered Hessian. What you'll do is the bordered Hessian. So HB in this case would be equal to 0, px py px py. These are the first order partial derivatives of the constraint, and these are the second order partial derivatives of the objective function. So fxy and fyy. So this is the matrix, and you will try to calculate the determinant. Okay, for maxima, what should be the sign for this condition to be for maximum? Okay, so in case if it is if this is going to be positive, then this is the point of maxima. So what you will have is okay, so what you will have is, let's calculate this determinant, and what you will have is minus px, okay, determinant of fxx, fxy, fyy, and one more thing which I haven't told you, that fxy and fxy, it should be actually fyx, but they are equal by Young's theorem. Okay, and plus py, which is px fxx py fxy. So what you will have eventually is minus px into fxx into fyy minus fxy square plus py px fxy minus py fxx. This is what you will have, and what you will have eventually here is px fxx fyy plus px fxy square plus py okay plus py px fxy minus py square fxx. Okay, this is what you will have. Well, what you eventually have is basically in place of what you can write in place of fxx is in case if you go back to the first order conditions, which is this, your fxx will be equal to